not Zoom, so it did not say recording in progress.
Oh,
We get a little pop-up.
Yeah, so do I.
yeah, it's recording.
All right. I've been working on the state desegregation. It's coming along well. I'm trying to set it up so they can easily generalize it, so it's taken me a little bit longer. But we'll see. Okay, and the little bar at the top needs to go to second monitor. Okay, cool. So I'm going to show you a couple things that Eli might know these things, hopefully, and he can feel free to chime in when I'm just wrong about something or when he can say it better. But I think there's a lot of things in Julia that you may not think about. So I just created an empty VS Code. It's totally new. I'm going to hit Control-Shift-P and just type Julia and make a new Julia file. So Control-Shift-P opens the command palette. Mac, I think, is Command. And you can do a lot of stuff from here. Like anytime you need to do an action, I'm just scrolling. It exists in here somewhere. One of the things that makes VS Code nice. Okay. Right now, I don't have anything running. I'm just going to type. You can type something and then hit Shift-Enter. And that will start the connected terminal. It takes a second the first time it loads up. Just come on. Let's go. There it is. You can also do that by holding Alt and hitting J and then R. And that will just restart that guy. So it's just a terminal connected to this editor. And it takes a second. And while it's going, I can type a function. So let's see here. I want, I'm going to make a function, and all it's going to do is print a couple things. Type of X. Oh, now it says error. Oh, okay, that's fine. I think it tried to run it while I was still typing. Okay, so all I did was made a little function, takes two inputs, X and Y. And all it's going to do is tell me what the types of those inputs are. So type of is just a function. So the type of 4 is an int64. So if I do f of like hello and 42, sure. Okay, and I put the $sign in the wrong spot. Should go before the parenthesis, so all of that is included. There we go. So if you're wondering what this $sign does, that's just a string interpolation. So it's saying, run this as its code, don't keep it as a string. So it just told me the type of each of those inputs. Cool. Okay. Now, here's the real magic of this. This is equivalent to this being any. So any just means any type. That's the default. And what Julia does when I give it something specialized like a string and then an integer, it makes a new function, like it compiles a new function with those types being specified. But I could actually just do that. Y int. I'll have it do what AI is telling to. Okay, so now you can see there's two methods. There's one that's the default, and there's one that's when I type a string in an integer. So if I rerun this, I get this one. Because Julia figures out the inputs are a string and an integer. Notice I didn't type int64. I just typed int. And that's because int64 is a subtype of int. Hey, oh my goodness, that actually worked. And int is not a real type. So can I do Yes, I can. Oops. Int is not really a real type. It's not a concrete type. So in Julia, there are abstract and there are concrete types. Concrete types are things that you interact with. Like if I do int of 4, okay, so y looks to be the integer 4. But if I do type of, I bet it is an int64. Int64 is a concrete type because it knows exactly what size it is. There's also int32. It's just a smaller form of an integer. Okay, so what I'm trying to get across here is that there are like abstract types and concrete types. And when you write functions, you can put either, you can specify either you want in the type declaration. And this is one of the things that makes Julia unique, is that you can get as specific as you want with these. So let's see here. Int 32. Okay, so if I do this, if I specify a function where it's a substring and an int32, I got to figure out how to make a substring. So if I do this, and I do y of 1:3, it's not 1:4, it's just hell. That's great. Let me see what type this is. String. How do I make a substring? Hold on. Eli, do you know a quick way to make a substring? I swear this one would have worked. I can probably just tell it to be. Okay, cool. So I've hacked this one. Okay. But when I do f of z comma 4, it goes to the default because 4 is an int64. Integers always default to int64. But when I do f of z comma int32 of 4, then it grabs this one. So you can see it returned this, or it printed that, which is what we did here. So you can get incredibly granular on these things, which is super, super nice for many reasons that I'll show you why. It's also the thing that sets Julia apart from a lot of languages. This is called multiple dispatch. And you can do this in C. Like you can define functions that take different inputs. But what it's not going to do, so let's see here. Let's see if I have a function that's f of x. Let's go substring again. String. This time, let's do int 64. So in other languages, you're not going to be able to do something like this because it's going to, when it's looking up functions, it finds this, and it's going to use the first one, I believe. The multiple dispatch is very special. And it creates, the reason that other languages don't do it is it kind of creates a combinatorial nightmare. Because if this is any, I can put anything there. So you sort of have an infinite number of combinations that you could have. But Julia is very good at figuring out which one is which.
And it's sort of one element that is key to the speed efficiency of Julia is the more tightly something's typed, the less work the computer has to do to figure out how to manage that variable. But if it knows instantly that it's an int32, that part of the sort of figuring out what it's managing there is done, and it can just like, okay, we've got an int32, and then it'll be sort of as specific as possible is much faster because less computational work to figure it out. But you can just say whatever, and it'll go as high as it needs to figure it out.
Yeah. This also affects compile times. Eli made me think of this. Because this is any, every time that I call it with a new specification, like if I put a symbol and a float there, it's going to compile a new thing. And that compilation is what is slow. The second time I run it, it'll be faster, but the first time it's going to compile it. So every time you call it with a new, with new inputs, if they're new types, if it hasn't seen them before, it's going to compile. Which is fine, but it's usually better to be specific because then it's less things the Julia interpreter has to worry about. All right, so far so good. I should also say that these two things are linked. So I just clicked over here and hit Control L. And F is over here too. So I can do F over there. And it works fine. The editor and the REPL are connected. So REPL, read, evaluate, print, loop.
You want to do F of a single argument?
F of 2 dies. Because I've only defined F to be on two things. I could define it. And then just sort of print ln.
Just defaulting to any.
That's just a single argument.
But the same function name.
Yep. Very convenient, very nice, because you could have things acting wildly differently, which is cool. Okay. So I've told you about types and I've told you about abstract types. Let's talk about interfaces for a second. Okay, I tested this. So let's see that this works. Abstract array. I want this to be a float. I'm going to tell you what all these things mean. Okay, cool. Thank you. Okay. So Julia has a lot of built-in abstract types. One of them being an abstract array. And I've told it that the inputs to this are going to be floats and that it's only going to be dimension 1. So it's just a regular vector. In fact, I've just made a regular vector. So what I've done, 3, 4, is I've made this. And the way, so this is going to be fun, the way that you define one of these things, so I'm not going to do this, but if I had two things here, then I would just have two of them. I would have two inputs. So I only have one input. That one input's a vector. And I'll do more of these. What did I deleted my parenthesis. And I get a lot of errors. Dang it. What happened there? Well, if I read the error, it starts here. No method matching size of test. The function size exists, but it's not defined for this. So the reason that happened is because Julia has these things called interfaces. And if I want to define an abstract array, I need to define these three functions with it. So I'm just going to go like this, bring this over. I'm going to close that. Okay. I need to define, base.size of a, it's a test. This is going to be, I'm not going to get fancy here. So all I'm telling it is that if I put this should be lowercase because it's lowercase size if I can read correctly. So all I'm telling it to do is that if I put a test in there, just give me the size of that vector. You could make this more complicated. You could make it less complicated. It just needs to return a tuple containing the dimensions of A. That's it. And then I need get index. So that's the next thing. Test, and then it wants an int. And this is just getting the ith index. So of course, I'm just going to refer back to data. And then the same thing here, base.get index I var arg int colon n. And all I'm doing is copying this right here. And this is going to just be that. N is not defined. Oh, this can be a 1. This can be a 1 because this is a 1. This number matches that number. But here's the difference. Now that I've defined those 3 things, last time I did A, I'm going to make this big, I got an error. I didn't actually run the middle one. There we go. You know, when you actually run your code, it runs. That's great. I'm just going to redo this. So it went from error to now it displays the way you'd expect. And because it's an abstract array, and I've defined the things I told it to, I can do things like add 2 to every element. This little dot means component-wise. So I didn't have to define any special code to do this. It just does it. Because Julia knows how to do this for an abstract array. So because it knows how to, sorry.
No, that's all right. Did you have to say base dot or?
Yeah, that's a very good question. Yes, you do, because I'm overwriting something from the base modules. Or I can show you.
Okay.
Let's restart it. I believe it will give us a warning. Takes a second. Come on. All right. First time it has to do something, it thinks about it. That's an error. Okay. And this one. Yeah, so this won't work. We'll do these 2. So I get the same error. I get the exact same error. And the reason for that is it made a new function called size and it overwrote the old one. So this is actually much worse. Because I think if I do, oh no, I think it's actually still fine. Yeah, I didn't break anything because this is defined on test. So this makes a new function called size. It doesn't add to the existing framework. To add to the existing framework, that's where I do the base dot.
Okay, yeah, this is a little deep in the weeds, but it's good for me.
Oh, and I've definitely broken it because I didn't do base size. Let me restart. And because I didn't do base.size the first time, the compiler is going to remember size. And it's just going to keep using that. Oh, and now I can go. I don't need to see the error anymore. Oh, there it goes. Wait, did it actually error? Is it doing? Did I break something? Why is it doing that? Zero, 1, 2. It's this one. Okay. I don't know why that worked once and then didn't work the other times, but this ... just means expand it so it's no longer a tuple. So it does it correctly. That's what I want. All right. And I could, I believe, add these together. But if you notice, it returns a vector. So notice it returns a vector. That's not always what you want, so you could also define addition. It's just base dot plus. And AI sort of figures out what it needs to do. Did I not do that right? Oh, no, I know what I did. I need parentheses around the plus. There we go. But now when I do type of, it says vector float 64. It still says it.
Should it be the test on B as well, separately?
Why is it still? Say that again.
Should it be instead of test A data plus B data, should it be test A data plus test B data?
It'll get caught in a recursive loop because it'll do this again.
Hmm.
Hold on. I'm not sure why that's. I think that's right. Okay, I can't see what I'm typing. That's always a problem. It's not parentheses. Oops. Colon. That makes a lot of sense. So now if I do type of A plus A, it returns a test. If I do A plus A, it returns a test. So I just wrapped that around there. This is a silly mistake, but you could also do like multiplication and power and stuff like that. So this is called an interface. Like I have an abstract type and it's saying you just have to define these and then you have it. And if I look at this, I could also define more stuff like set index. So what does set index do? Well, I can get A of 1, but I can't do A of 1 equals 3 because set index is not defined. So I define set index, then it'll do what I want, which is cool. Yeah, and you get length. Does length really not work? Length. So length is just going to be the product of the size of A. So it defaults to 3, but I could overwrite that to be different. Right, let's do size of A. So the first dimension has 3 elements, which is pretty cool. And that's coming right from here. All right. And you can define it for different indices and stuff like that. So, one bad thing about structs, if I put an n in there, it gives me an error because you can't redefine a struct. You'd have to restart all of Julia to redefine your struct. This is going to get fixed soon. I think 1.12 or 1.13, they're trying to do that, but until we get there. Okay, a couple more things. So I just hit right bracket to see the package manager. And you can see it says version 1.11. So this is my base environment. And these are the packages that I have installed by default. So when I'm doing a project or I do something, I almost always make a new environment, which I could do pretty easily here, but I'll do that in a second. But the packages that I tend to use most frequently, I just have installed in base, so I can just get up and going. The exception there is revise. If you don't have this installed, you should. And I'm going to show you what it does here in a second. Easy to install. You just add revise. It's not going to do anything for me because I already have it. And I'll show you the real magic of what this does in a second here. Okay, it's not. No changes. Does not going to do anything because I already have it. Okay, so here's what I want to do. I don't think I am in the correct place. Come on. This is just a terminal. Thank you. Okay, cool. So all I did was changed into this directory, open a terminal, and I'm going to start Julia. I'm going to go into the package manager, and I'm going to type generate basic test.jl. So there's fancier ways to do this. I realize this is probably too small for you to see, and nobody yelled at me. I apologize. What I just did is I generated the basic things I need for a project. So what I'm going to do is I'm going to open a folder. So I'm going to open a workspace. I click the little things, open a folder. It was in Documents, Julia. What did I call it? Basic test. There it is. And just hit select folder. Go ahead and save this Documents into that directory I just created because let's call it main.jl. Because it's going to restart my directory, and there it is. I also have here source, and inside of source, I have something that says basic test, and I have a project.2ml. So this was all generated automatically, except for main, because I just defined that. Okay. Now that I'm here, see this Julia Env 1.11? Oh, in fact, it just came up and told me, hey, you have a da, 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 da. If this doesn't come up, I can just click here and then select the environment that I'm in. That'll work for any environment. You don't have to do it as a package. So I just did the Alt-J R thing. So I held Alt, press J, press R. Now it's going to start Julia. It's going to take a second. If I go into the package manager, it says basic test because that's the name of my environment. And if I type ST, there's no packages added because I didn't add anything. It's just an empty environment. That's totally fine. Okay. So here's what I'm going to do. I'm going to go into here. I'm going to, I'll just show you what happens. So because I'm in my basic test Julia environment, I have access to this module. And this should say hello world. Oh no, I'd have to do basic test.greet. Hey. So functions that I define in here are available when I do using basic test, just name.greet. If you want to actually use it, oh, hold on a second. If you want to actually use it without doing the name dot, just export that function name. Okay. So when I run greet, it doesn't work. I get end if variable error. If I save this and then run greet, it works. So that's pretty important what I just did there, and it's kind of subtle. The only thing I did was saved this, and that made this work. I could do it with a function like f. Right? So I'm just going to save this. Just going to hit Control S. Didn't run anything. But now I should be able to do f of 5. And it works. Also, it overrode this f. Oh, no, this f was never defined. That's what revise is doing. So I could have done this. I could have done g of x equals x cubed, export g. And this time I'm not going to save it. This little dot is not going to go away. Oops. But I'll run this with Shift Enter and run that with Shift Enter. And then G is defined. The number of times that I've forgot to Shift Enter is a lot. So I'll like define a function here. Like I'll define an h. H of x is just going to equal x. And then h. And then I go over here and I do h of 1. And it doesn't work. If I just save it, which I do 10 billion times, I do it pretty much every time I type a letter. I'll just save it because it's Control S. That's what revise is doing. That package revise that's in my base environment, whenever I save a Julia file, then it adds all that stuff to the, it compiles all that stuff and makes it available. Hugely useful. So like I could change this to be x over 2. All I have to do is save, and now it's x over 2. It saves a lot of time and just annoyance. Just general annoyance. Okay. I can create custom types. Custom.
I was just going to add.
Yeah, go for it.
I was just going to add, if this is a very small module, so you could sort of, run each function and save them. But if you're working on a whole package that sort of got various scripts and they interact, the idea of running each, you can't really just run each individual function to sort of compile it in the same way. The revise is really more essential in that case, I think.
Oh, it's very nice. So I'll do what Eli's talking about here. I just made a new file called structs, and I saved it inside of the source directory. So what I'm going to do is I'm going to include structs.jl. Save it. What does include structs.jl do? Well, it includes structs.jl, I guess. So basically, whatever I type here is now available over here. But what do I want? I want an abstract type. Abstract complex number. Julia already has a complex number class. And if I do, all right. Okay. So with this abstract number, I could make two functions like real, x abstract complex number. And this is going to throw an error that says not implemented. Same with the imaginary part. Because this is, so basically what I'd be doing is I'd be saying, I'm providing an interface for complex numbers, but you have to tell it what the real and complex parts are, the real and imaginary parts. So when I go down here, okay, I'll let AI fill it in because AI does know what it's doing in this case. AI is really great when you're doing things that are not hard. Gives you a real good false sense of accomplishment. Bring this over here. Now what I want to do is I want to export my complex number, real and imaginary. Save that. Let's save that. Let's actually see if this works. My complex number. Hey, it worked. And then I could probably, let's do z equals real. It did not like real. Did it like imaginary? Nope. Sometimes it doesn't. I'll just hit enter on that again. And now I bet Why did that not work? Come on. What? Am I doing it? Let's try this. Z is not defined. Oh, maybe that's what I was doing. Nope. Let's restart it and try it. So all I did there was Alt-J, Alt-R. Maybe I've typed something wrong. The answer is going to be AI. Don't trust AI. Come on. Come on. Okay. Basic test. Takes a second because it's pre-compiling. Am I just doing this wrong? Like, what am I doing wrong? It doesn't make... Uh-huh. Uh-huh. Eli, do you see what I'm doing wrong? Ah, that's what it is. I should have read the error message. Looks like 2 or more modules export. So my guess is that real is already the name of a function for the built-in complex type. So what I'll do, I'll probably do base dot.
Or my real or something, one or the other.
Yeah. Now I'm just being lazy. I'll do the Eli idea of my real and my imaginary. But if I change it here, I gotta change it here. And my, okay, there it goes. Yeah, there were conflicting names. But the real part is 3, the imaginary part is 4. I could down here define a function that's called conjugate, right? And I could have it act just like this. And I'll do basic test dot conjugate of z, and it works great. The problem with this in particular is that if I define another complex number type, it's not going to have conjugate. Conjugate. Why did I do conjugate? What? Conjugate. So if I defined another one, so I do complex number 2, complex number 2, and I do basic test to z2. It's not going to have this same conjugate feature. And method error, because I haven't defined it for that. So the question becomes, how do you do that? Well, X, let me think about this for 1 second. Okay. Here's the naive way to do it. So what I want to do is I just want to copy exactly what I did here of x.real. Okay, you don't want to do that. That's a bad idea. My real x, I'm a minus. As a best practice, this is bad. I have a function that retrieves this. I should be using the function. And this is actually not how you do this at all. So this is going to break right when I do this one. So this is telling me, okay, what's it telling me? No method matching conjugate basic number 2. The function, it's a big long, oh no, it's right here. No constructors have been defined for this. So I have to do something a little bit different. So this is going to be kind of weird. Abstract complex number. And then now it works. Works exactly how you'd expect. What did I just do? So what I just did, okay, we'll look at this and then we'll look at this. So I want something here that is a subtype of an abstract complex number. So that's exactly what I tell it here. I put something where that thing is a subtype of abstract complex number. And I just take whatever that type is and the conjugation code. Because conjugation just makes the imaginary part negative. This is the other reason why you don't use dots, why you use actual methods. Because I don't know what these things are going to be called. I don't have to call them real and imaginary. I could call them dim1 and dim2. Actually, I don't want to do it there. I want to copy. I want to do 3. dim1. Because as we all know, you can think of complex numbers as just a vector in the complex plane. Or a vector in R2, right? It's just two points, A, B, in the complex plane. But what's number 3? I didn't save it. That was probably the issue. And I can still do conjugate. And it gives me the right type. So it's complex number 3. And then the imaginary part is negative. Neato, right? Doesn't matter what these names are because I'm referring to the actual functions. All I'm telling you is that you need to define these to give me the parts that I want. Don't care about anything else. Okay, here's not necessarily the last thing we'll talk about. Let's go to here. Let's export conjugate. Conjugate, so I don't have to keep typing it. Are you guys familiar with docstrings? Eli is for sure because he yells at me about writing them more.
Not really.
So a docstring. Oh, I should also say this is an inline function. There's 2 ways to define functions in Julia. X, T, where T. I'm just going to comment that out. These 2 do the same thing. I'll use this inline one. There are compiler advantages to this, but it's only useful for really simple functions. So anything more complex than a one-liner gets thrown into this. So here's how a docstring works. All I'm going to do is copy this part, put it there, and tab it over. The way that I did that is I held Control and hit the right bracket. Left bracket goes backwards. I've started doing that because AI uses tab for its autocomplete. So I want to be like, oh, I want to tab this over, and then it fills that. And it's like, don't do that. Not tab. The conjugate of the complex number x and return a new instance of type t. And I've spelled conjugate wrong. So now because I've actually exported it, I can just do conjugate. It still works. The purpose of this docstring, I've forgotten what conjugate does and what the inputs are and what it returns. And there it is. So what I did is I typed a question mark, and then I just typed the name of the function. Notice how this part is in blue. That's because it's tabbed over. It's a markdown thing. This, can you guys see that the X and the T are blue? Okay, I can't because I'm colorblind.
Yeah, they are.
Backticks. Save it, and then anything you put in backticks is going to be that a little bit highlighted. Again, that's markdown. If you know markdown, it's just markdown. This is also, I'm going to get rid of that because I don't need it. This is also how, go to GitHub. Let me go to some little package here. Oh, that is very zoomed in. If I go to the API reference and I just click one at random, that was a terrible one to click. This documentation, this is just grabbing the doc string. So this looks exactly like in the code, that's what it looks like. In fact, yeah, let's see if I can find it. Let's see if I can find generate report. That's probably a pretty easy one to find. Source, report. There it is. There's the doc string. There's how it looks in the documentation. I could probably just gonna click source right there, huh? That would have been smart. I should talk about documentation at some point as well, like how to generate the documentation, because it's very not hard. It's just very annoying to get set up first time. But yeah, it does it all automatically. Questions, comments, concerns, anything? I don't know why, but when I write something, it takes 50 minutes to read every time. Tuesday, Thursday classes were a nightmare.
So when you say documentation, are you talking about going beyond just doing things in Markdown, but actually like be able to translate things to a PDF or?
Yeah.
Okay.
What I mean when I say documentation is essentially a website that looks like this. So I can show you where this is generated. If I look at docs and I click on, I'll look at make. See how it has introduction? Okay, I can't point at the screen. Introduction, tutorials, mathematical background API reference.
Mm-hmm.
Introduction, tutorials, mathematical background API reference.
Okay.
And you see this docs.md. Oh no, I don't want that one. I'll look at tutorials, getting started. I'll look at this one right here. So where is that? That's going to be, notice getting started is a menu, getting started. And I want this. I want tutorials, getting started, introductions. It's going to be source, tutorials, introduction. It's just a markdown file that I've written. I can look at it raw because that's what the code actually looks like. This translates to this. And you can export this as a PDF. I did that when we were doing the USDA ATM project, agricultural trade multipliers. And once I got it working, it was real nice, very easy. And you can have it generate the PDF when you push it up. So it's just ready to go. I'll talk about this though at some point. It's very cool. Yeah, and you can make these things be as disorganized and horrible as you want. As you can see, like I've done here. Yeah, it's actually not that bad. You could have different subdirectories. If I look at jump, Julia jump GitHub, and I look at their source, and I look at containers, this is a package. Is it? Yeah, this is actually a package within a package. And you can tell because this is a project module. So it's like a module within a module. So you can like nest these things together. And if you're like, oh man, if I look at the jump documentation, looks the same. And that's not because I configured it to look the same. It's because, where is this? It's right here. If I go to their docs and I don't know, click on their make, it looks exactly like ours does. Theirs is more complicated because jump is more complicated. But somewhere here, they have this. And you can see all the menus they have, and that's just how it's set up. So the only reason ours looks the same is because neither of us changed the default formatting. Which you can do, but why fiddle? I think I hit all the things I wanted to hit. So the big takeaways, specificity when writing functions is really useful. It's better to be, you go away, you get big. It's better to be more specific than less specific. This is also a really great way to add default behavior. Like I could have this throw an error if I wanted to, being like, hey, it's not defined for these. We do that anyways. If you are making structs, it's almost always a good idea to do an abstract struct and define all your functions on that. Because then if you extend it, like you make another complex number, you don't need to rewrite all your code. It just works. Don't get field names with the dot, like I've done here. This is bad. Make functions to do that, because then if you change the names, super easy. It's just automatic. You just have to change it in one spot and it updates everywhere.
What do you mean the names?
Like if I change this to say Eli, all I have to do is change this to say Eli. Oh, this is a great situation. Eli, this is great. If I change this to be Eli, because for some reason, real numbers are now called Eli numbers, right?
Oh.
This is great. This is great. I forgot to change this. Now all my code doesn't work. My code doesn't work anymore because this. I would need to update this to say Eli. Because now there is no real, it's called Eli. So everywhere in the code that I had x.real, where x was a complex number, my complex number, I would have to change that to say x.eli. If I had just used my real everywhere, that's all I need to do. And then it's done. Should undo that though. So I'll save this and I'll push it up to GitHub. So you can at least see the code again and be like, oh yeah, I remember some of that. And I'll get the recording posted.
Okay, thanks.
Yeah, of course. Yeah, I've been deep into disaggregating the state stuff and trying to make it better. So I figured it'd be a good diversion to just talk about Julia for a while. Oh, and also, if I look at, so this is MPSGE. I have a file called structs because I'm not original. I'm going to make this better at some point as well. The very first thing I do is I define some abstract types. The very, very first thing I do, this whole thing right here is just abstract types. Because then when I go down here, Let me. Okay, so I've got my abstract types. When I go down here, I define a bunch of functions based on these. Oops. And I'm telling it, this is not great, but it's mission specific. These are the things that need to be in the fields. So if I update that, I need to update all of these. But when I actually make a sector, it's just a scalar. Okay. It's just a scalar variable, which is defined right here. A scalar variable is just a special variable. And an index variable is an array. So somewhere here, I've probably defined all the stuff. In fact, it's right here to make it be an actual array. Which is cool. See, there's the get indices, and there is size. And then I define a couple extras. We define a couple extras. Yeah, I have to refactor a lot of this code because it can be better. But the benefit is that if I refactor it and don't change these functions and just have them do what they're supposed to do, nothing at all happens. Nothing bad happens. It just works. Backwards compatible. Whereas if I change name to be something else, then everything breaks. It's all horrible. All right, I should stop because it is 50 seconds over.
All right. Thanks a lot, man.
Yeah, anytime.
All right. We'll
Thank
see you
you,
next
Mitch.
week.
Yeah. How do I stop recording? There we go.